Hey y'all, it's Miss Rudd, and today we're going to be talking about classifying rational numbers. So go ahead and pause this video to print out the notes or while you draw this in your ISN, and then when you're ready to get started, go ahead and push play. So in this first part of this funnel, we have an R. The R stands for rational numbers. So rational numbers includes zero, positives, negatives, fractions, and decimals. If you need to make a note for yourself that I drew this 1/2 right here to represent all fractions and this dot to represent all decimals. So some examples of rational numbers are 2, 0, -2, 3/4, and 4 5/10. The I stands for integers. So integers includes zero, positives, and negatives. So some examples would be 2, 0, and -2. If you look, those are the same first three numbers that we used for rational numbers. So those three were able to fall down the funnel into integers, but 3/4 and 4 1/2 could not, because integers don't include fractions or decimals. So the +2, the 0, and the -2 are also classified as integers. The next section, the W, stands for whole numbers. Whole numbers include 0 and positive numbers. So if you're looking at the examples above, the only two that could fit into whole numbers would be 2 and 0, because whole numbers don't include negatives, fractions, or decimals. And our last section, the N, stands for natural numbers. And natural numbers include positive numbers. So go ahead and make a note over here that these are our counting numbers. So typically when you start counting, you count from 1, 2, 3, 4, 5, and so on. You don't typically start counting from 0, so natural numbers only include all of the positive numbers. So if we're looking at the same examples we've been using, the only one that could fit into natural numbers is 2. But if you notice, 2, technical difficulties. 2 can be classified as a rational number, integer, whole number, and natural number, but natural number would be the most specific place that 2 belongs. Okay, go ahead and pause this video and take a second to draw this if you weren't able to print it out, and then push play when you're ready. So this is just another way of looking at the funnel. So if you look at our first picture, it's a picture of a funnel, and the second picture would be what it would look like if we were to look down into the funnel. So this is the biggest part of the opening, which is our rational numbers. And this is the biggest part because it includes the most numbers. So it includes our positives, negatives, zeros, fractions, and decimals. And our second part is our integers. And it's a little bit smaller because it only includes positives, negatives, and 0. The third part is whole numbers. Which only includes our positives and our 0. And lastly, we have natural numbers, which is the smallest because it only includes 0. I'm sorry, it only includes positives. My bad. There we go. Natural numbers only include positive numbers. So take a second as we go through our vocabulary. If you feel like I'm moving too fast and you need to pause so you can write it down, go ahead and pause the video whenever you need to, and then push play when you're ready to move on. So in your ISN, you're going to write 4 vocabulary words. So the first one is rational number. So a rational number is any number that can be written as a fraction. This includes terminating and repeating decimals. So we're going to learn about those two in just a second, but make sure you write all of this down. So rational numbers is any number that can be written as a fraction, which includes terminating and repeating decimals. So some examples of rational numbers. Let me change this. There we go. Some examples are 3.25, 1.5. And the reason 3.25 is up there is because it can be written as 3 1/4. So it could be written as a fraction if we wanted to. 1/3, 7, 200, -4, 12/6, and -8 1/7. So notice here, this 12/6, that could also be classified as a natural number because if we were to divide 12 divided by 6, we'd get 2. And 2 is one of our counting numbers. So the most specific place for 12/6 would actually be natural numbers, but we can also include it in rational numbers. Our next definition is terminating decimal. So this is a decimal that ends. So an example, or a few examples of terminating decimals are 0.2, 0.625, negative 1.5, and 4.75. So if you notice, all of these decimals come to an end. They don't keep going. So they would be terminating decimals. Our next definition is repeating decimal. So a repeating decimal is a decimal that repeats or has a pattern that goes on forever. So some examples of repeating decimals would be 0.333, and I'm just going to put ... because it goes on forever. Another example would be 0.1666666 ... because it goes on forever. But only the 6 continues. And this last one is 0.181818 ... So if you notice here, this one's a pattern that continues forever. Oops. And our last definition is bar notation. So bar notation is what you see, what I did in the first one. Here, it's the bar over the number that repeats in a repeating decimal. So you can kind of see I did it up here. This 1.8, I put a bar over it because that tells us that it repeats forever. So some examples would be, oops. The decimal 0.545454, and it keeps going. Instead of writing all of that, we could just write 0.54 with a bar over the top. Oops. Sorry, y'all. Okay. And our next example is 0.5833 ... So those 3's are just going to keep going on forever. But instead of writing all of that, let's actually make this a negative. Negative. So instead of writing all that, we can make it negative 0.583 with a bar over the 3 to represent that the 3 repeats forever. So now we're going to move on to some examples. So this is just like what you saw on your first page. So you're going to try to put these numbers in the most specific place on, remember this is like if you're looking down into the funnel. So we can also call this a Venn diagram. So put these numbers into the most specific place on the Venn diagram, and when you think you're ready, pause this video and do that, and when you think you're ready, push play and check your answers. All right, so these are the answers that you should have gotten. And if you notice here, yes, this 12/6, this looks like a fraction, but if you actually divide 12 divided by 6, you get 2. And 2 is a natural number, so the most specific place we would put that is here in the natural number section. All right, and then this is also one I want you to try by yourself. And when you think you have the answers, go ahead and push play and check your answers. So you're identifying them into the most specific. All right, so these are the answers you should have gotten. Natural for 72. This 50 divided by 5 would also be natural because, again, if we take 50 and we divide it by 5, we get 10. So it's not, this is a fraction that could be simplified to a natural number, so that's why it goes in that category. We have integer because it's a negative, rational because it's a decimal, rational, decimal, rational, this is a repeating decimal. You see the bar notation. Rational because it's a fraction that can't be simplified to anything else. Integer because it's a negative, and natural because technically this is a positive number, and if we wanted to, we could totally count to 902, but we're not going to do that. So that is a natural number. Okay, and this is your homework for tonight. Go ahead and get that done, and then you have Imagine Math benchmark due on Friday, September 11th. Have a great day.